we know that the three equations of motions are uniformly accelerated motion. Okay, equations of uniformly accelerated motion. There is v equal to u plus at, s equal to ut plus half at square, and number 3 v square minus u square equal to twice as. Okay, now we will discuss today how can we verify these equations. Okay, that means proofs. Let us see now proofs of these equations. Okay, for that now see number 1, we have to prove v equal to u plus at. Okay, now see, consider a body moving with an initial velocity u. Okay, moving with an initial velocity u. The acceleration of the body is supposed to be a. Okay, acceleration of the body is supposed to be a. Then what happened? Since because the body is moving with an acceleration, so after time t, its velocity will change to v, isn't it? Because it is moving with an acceleration. Okay, so initial velocity is what here? That initial velocity equal to u, final velocity equal to v. Okay, time is t. Okay, time equal to t, isn't it? So therefore we get what? Acceleration. We get acceleration equal to what? Acceleration equal to change in velocity. Okay, change in velocity divided by time. This is the formula of acceleration, isn't it? So change in velocity divided by time. We know this is the acceleration. Now see the change in velocity. Initial velocity is u. Okay, initial velocity is u. And final velocity is v. Okay, so what is the change here? Change is always final minus initial. So what is the change in velocity? Let us see here. Change in velocity equal to final velocity v minus u. Okay, final velocity v minus u. Okay, this is the change in velocity. And here you see that acceleration equal to what? Change in velocity by time. Okay, so change in velocity we come to know v minus u. So therefore what? Acceleration equal to acceleration is represented by a equal to v minus u by t. Okay, so what we get from this? Let us cross multiply this. T here divide goes to this side. Okay, then it becomes at. Okay, equal to v minus u. Okay, so we get the equation here. U comes here. Okay, so u plus at equal to v. U comes to the left side, minus u becomes plus u here, equal to v. That means we can write v equal to u plus at. Okay, so this is our first equation. From the definition of acceleration, we derive the first equation of motion. Okay, v minus u, v equal to u plus at. Okay, now see the second motion equation, that is s equal to ut plus half at square. Okay, it is distance and time relationship. Okay, this equation is also known as distance time relationship. S represent distance, okay, and here t represent time. Okay, so this equation is also called distance time relationship, remember. Okay, so let us see here that the initial velocity of a body be u, acceleration a. Okay, and after time t, because the body is moving with acceleration a, so its velocity will change after time t. So what happened there, that after time t the final velocity be v. Okay, final velocity be v. Now already we have discussed about the concept of average velocity. Okay, when the average velocity, we have discussed this thing. Okay, when the body is moving with uniform acceleration, uniform acceleration. Okay, when the body is moving with uniform acceleration, what we say, that average velocity, okay, average velocity is equal to, we take average velocity equal to what, initial velocity plus final velocity divided by 2, isn't it? So we have discussed this thing, that when a body is moving with uniform acceleration, then its average velocity is taken to be the average of initial and final. Okay, so initial velocity plus final velocity by 2. That means we can write what, we can write that average velocity equal to u plus v by 2. Okay, u plus v by 2, this is the average velocity. Now if the body is moving with this average velocity, okay, with this average value, average speed, then how much distance will it cover? We know that what, we know that distance, average velocity or average speed equal to, we know that average speed equal to distance by time. We know this thing. Okay, distance divided by time. Okay, so we know this definition of speed. Now what happened here, what is the distance from this? Distance equal to what? From this we get distance equal to speed into time. Okay, we get this. So this speed is here what? This speed is here average speed. Okay, we are talking about average speed here, that when the body is moving with average speed, from the beginning, if it is moving with this speed, okay, the average of these two, then how much distance will it cover? We know that in the average velocity also, total distance by total time, distance is the same thing. Okay, so whatever velocity it is moving, it is covering the same distance as a whole. Okay, so here also what we can say, write the now equation here. Speed means here what, u plus v by 2 into t. Okay, and distance, we know distance is represented by s, so we get this equation here, s equal to u plus v by 2 whole into t. Okay, now see here one thing, we in the equation what, it is s equal to ut plus half at square. Okay, in this equation there is no v. V is not present in this equation. Okay, so but here what we get, u plus v by 2 into t, so we do not need v here. Okay, we have to replace this v. Now let us see how can we do that. Okay, so already we come to know that v equal to u plus at. We know this. Okay, let us use this equation, this value of v in this equation. Okay, equation number 1, suppose it is equation number 1. Okay, now see, let us use the value of this. From this what we get, 1 implies s equal to u plus, okay, v means u plus v means here we have to replace the v. Okay, here you see here this v will be now replaced by what, u plus at. Okay, so we will write u plus at, u plus at, okay, divided by 2 into t is there, okay, in the equation. Now let us see. So let us see now, s equal to this t will multiply the whole equation, okay, it is twice u plus u twice u, okay, into t, okay, plus a t into t, a t square, okay, divided by 2. Okay, now see the next step. These two dividing both the term here, there are two terms here, twice ut and another term is at square. So these two dividing the both terms, so we can write twice ut by partially dividing them, this plus at square by 2. Okay, we get this. So from this what we get, 2 cancel here, ut, okay, it is ut, it is at square by 2, that means we can write it in this way, half a t square. Okay, so what we get, s equal to, we get s equal to ut plus half at square. We get this equation finally. So s equal to ut plus half at square. Okay, we get this equation from the concept of average velocity. Okay, so note down this. Let us see the third equation of motion, v square minus u square equal to twice s. Okay, we are going to prove this now. So let the initial velocity of an object be u, okay, and it is moving with an acceleration a, okay, and after time t, and the velocity of the body will become v. Okay, so let us again use the concept of average velocity, that what we come to know, that average velocity is equal to what, v u plus v by 2. Okay, this is the average velocity. Okay, so from this average velocity we can find the distance again. Okay, so let us see now what is the distance. Distance equal to speed into time. Okay, therefore distance equal to first write distance equal to speed into time. Okay, speed into time, this is the distance, okay, covered by the object. So now let us see here, let us put the values. Distance means we know s, and speed already we come to know, it is average speed. Okay, u plus v by 2, speed is here u plus v by 2 into time. Okay, into time. So we get this equation. Now if you see the formula here, if you see the formula, what is there in this formula, we need v, we need u, okay, we need a and s, we don't need t. Okay, t is not required in this. Okay, so from this equation we have to replace the t here, we have to replace t, okay, because we don't need this t here. And so how can we replace this t? Now let us see this. Suppose this is equation number 1, it is equation number 1. Okay, now already we come to know that v equal to u plus at, v equal to u plus at. Okay, so let us find now from this value of t, what is t. So v minus u equal to at. Okay, so what we get from this, that t equal to v minus u by a, this is t. Okay, so from this equation we come to know t. Okay, now we will put the value of t, value of this t in the equation number 1. Okay, in the equation number 1, this t will be now replaced by this v minus u by e. Okay, now let us see here that 1 implies what we get, as equal to, we have u plus v by 2. Okay, and t means we write what is t now, v minus u by a. Okay, so see here, v minus u by a. Okay, so what we get now, see here, here it is u plus v, it is u plus v whole into, we can write v minus u, we can, and 2 into a, twice a. Okay, so we get this equation from this. Now let us see, this is s. Okay, this is s. Now twice a goes there, it is twice as. Okay, now see here, u plus v, or you can say v plus u, and it is v minus u. Okay, v plus u, v minus u, so we get what, it is a formula like a plus b whole into a minus b. Okay, so a square minus b square, isn't it? It is like a square minus b square. So it is what, v plus u whole into v minus u, that means v square minus u square. Okay, so we get this third equation, isn't it? This is our third equation of motion. Okay, so we get this derivation now using the concept of average velocity again. Okay, so note down all these things.